Alright, so welcome to the first installment of the CubeCraft Development Talk series, where we're getting awesome devs within the Minecraft community to come say hi to budding developers, both our junior developers, our general development team, and anyone who wants to come and say hi. Today we've got SB Prime coming in, who is going to be doing talking on threading. I'll hand over to him in a minute. Just a few housekeeping stuff beforehand. Those who have applied for the junior development program, I've got back to some of you. I still haven't got back to all of you. So if you haven't yet heard back, that doesn't mean anything. It just means I haven't got down to you in my spreadsheet yet. Without further ado, I shall now hand over to SB Prime, who will introduce himself and his talk. So SB, over to you.
Hi everybody. I hope that you can hear me. Well, I'll introduce myself first. I'm a senior developer at a company here in Poland. I've been working on computer programs for over 20 years now, and in my free time I make some plugins for buckets, for Spigot. You may know me from the AsyncWorldEdit plugin. So, I see the chat. Somebody does not like my mic. Well, sorry, I do not do streaming or YouTube, so I don't have a professional mic, so you have to live with it. Sorry. Okay, without further ado, let's go to the presentation. I'll wait a minute until you all have the stream. Hopefully it will work. Okay, I see that you already have the presentation. Let me hide Skype. Okay, I was asked by CubeCraft to give a short talk about multithreading and how multitasking works in computer applications, and especially in Bukkit, and how you can do some stuff with it. If you are a professional developer, I think that you will be bored, because I'm planning on covering only the basics of the basics. So let's go over the agenda now. First, I would like to talk about the difference between multi and single-threaded applications. Next, I'll show you how to access data in multi-thread applications. Then I will talk briefly about the application main thread. Finally, I will go over multitasking in Bukkit and what you can do with it. And on the end, I'll say a few words how the inner works of AsyncWorldEdit are made. Okay, let's start with single versus multi-threaded applications. On this slide, you can see a sample single thread application. It has a user I/O, a game logic, and data rendering. By data rendering, you could say that it's rendering data to screen. Oh, I forgot to mention that after the presentation there will be a Q&A section. I'll try to look at the chat whenever I have time, but please don't ask questions, because I might not see them. I see there's some chat going on, so the question might scroll up for me, so I might not see it. Okay, let's continue with the presentation. in a single thread application, each task, so as I said, for example, user IO, game logic, render data, is done one after another. So first we read user IO, then we process some game logic, and finally we render the graphics. And back again, we read the user IO, etc., etc., etc. Well, this approach has its advantages and disadvantages. In my opinion, the biggest advantage of this approach is that it's fairly simple to implement and to maintain. But this approach has a fairly big disadvantage. First of all, since all sections of the code are executed one after another, if one section lags, the next section will fall behind, or it will be also lagging. For example, if the game logic lags, the render data the data rendering will be also late, so you might experience TPS drop, FPS drop, or simply lag. Well, don't get me wrong, this approach has its benefits because, as I said, it's simple. It's a great approach if you want to calculate data, so you have an input, some logic, and output. It's great for analytics and science applications. Okay, next slide. In a multi-thread application, each task is run by a different thread. So user IO is running on a different thread, game logic is running on a different thread, and render data rendering is also running on a different thread. In a multi-thread applications, we need an additional thread. Sometimes it's called a main thread, main application thread, main server thread. This thread is responsible for managing the whole life cycle of the application and starting, stopping all other threads, and sometimes synchronizing the data for the threads. The main thread is usually the first thread that's started in the application, and it's the last thread that's stopped in the application. Well, as you can see, this approach is much more complicated than the single thread approach, and it has some traps, mainly regarding data accessing. The big advantage over a single thread approach is first of all better utilization of modern hardware. As you might know, or probably everybody knows, that modern CPUs have multiple cores, so it would be a waste of power if you would run only a single threaded application on them. Of course, operating systems run multiple applications, so they are utilizing the hardware, but if you have a single thread application, it's not as good as a multi-thread application. Okay, and since each thread is running independently, there is no danger of lagging other threads. So, for example, if the logic is falling behind, we won't lose user IO. If the logic or the user IO is running slower, still we can render the data. Of course, if we need data from the user IO or game logic to render the graphics, the FPS might drop, or you might experience graphic glitches, but that's a completely different subject that I'm going to talk just in a minute. Okay, Now let's talk a bit about accessing data in a multi-thread application. Here is a simple example of an application that reads data from the bank account and does some simple operation on it and writes it back. First, it reads the data from the bank, so we have 1000. Then it subtracts 100 from the local variable, so we get 900. And finally it writes back the data to the bank account. Okay, now let's look at the same example, but let's assume that there are two threads running concurrently. So the blue is the thread 1, yellow is thread 2. Keep in mind that those sorry, I was looking at the chat now. Okay. Okay, where were I? The blue is the thread 1, the yellow is thread 2. So you need to remember that each thread can run simultaneously, and this order of execution is only to show you what could happen if you write your application incorrectly. Okay, first thread 1 and thread 2 read data from the bank account. Each of them has received 1000, value of 1000. Secondly, thread 1 and thread 2 subtract locally the value of 100 from the previously read bank account. So we have 900. And finally, thread 1 tries to write the data to the bank, and thread 2 tries to write the data to the bank. Each of those threads has a local state of the bank account that says, hey, there's should be 900 in the bank. So it's both threads write 900. But since we subtracted 200 twice, we expect to have 800 when those two threads finish running. So there's a problem. And how to fix this problem? Well, simply, we need to use some mechanism that will allow us to synchronize the data access, actually. So first, let's talk about a semaphore. It's the most primitive and the most basic data synchronization structure that is available in practically any OS. Each semaphore has a state. This state is usually a number and a list of available states. I'll cover that on my next slide. And the semaphore has two functions, up and down. The up function iterates the state from current state to the next state, to the next state, to the next state, until you reach the last available state. And the down method iterates the state backwards from the last state to the previous until it reaches the first state. When the first state is the current state of the semaphore, and the thread tries to use the down method, the semaphore won't allow it and will put the thread into sleep. Okay, next slide. As I said a minute ago, there are each semaphore has a a list of valid states. By this, you can devise two types of semaphores. The first type is a binary semaphore that has only two states, 0 and 1, or up and down, and a multi-value semaphore that has states from 0 to n, or any iteratable values. A binary semaphore allows you to limit the access to only one thread, and when you are using a multi-value semaphore, you can allow multiple threads to enter the critical section. It's sometimes useful, but in most cases we will use a binary semaphore. Okay. Let's look again at our bank application example, but this time let's use a semaphore for data accessing. So I made only two small modifications. We have a semaphore down and a semaphore up. Semaphore down, semaphore down, semaphore up, semaphore up. And similarly, as before, the blue is the thread 1, the yellow is thread 2, and we want to run them concurrently. Okay, so in the bank we have 1000 bucks. We start our two threads. First, thread number 1 tries to pull down the semaphore. The initial state of the semaphore was up, and thread 2 tries to pull down the semaphore. Let's assume for this example that thread 1 was a bit faster, and it was the first one that pulled down the semaphore. Therefore, the semaphore state is now down, and when the thread 2 tries to pull down the semaphore, it won't be allowed this operation, and it would be sent to sleep, and it will be waiting for the semaphore to have an up state. Okay, now thread 1 reads the bank account, subtracts 100, and writes back the value to the bank. So we have 1000, 900 after subtraction, 900 in bank. Finally, when thread 1 is done, it sets the semaphore up and finishes running. When you put a semaphore up, it automatically informs thread 2 that the semaphore is up. Therefore, the thread 2 will put the semaphore down, and it will continue its execution. So in point 7, the semaphore will once again be down. I'm looking at the chat. What's the difference between a log and this? I'll cover that on the next slide, or yeah, on the next slide you should have the answer. Okay, let's get back to our example. Thread 2 reads the data from the bank, subtracts the values, the 100, writes data back to the bank account, and puts the semaphore up again. You need to remember to always put the semaphore up. And in the result, we have 800 in the bank, and we expected 800 in the bank, so our program is fixed. Okay, let's continue. Critical sections. This is something that who was it? Okay, Xlordax. I don't know how to pronounce your name. Asked. Basically, a lock or synchronized in Java is a critical section. When you want to restrict access to a piece of code to only one thread, you can use critical sections. In most high-level coding languages, this is the most commonly used synchronization method for accessing data. And yeah, as I said, it simply allows you to restrict the access to a certain piece of code to only one thread. You could, of course, use the same lock for multiple blocks of code. Well, this is in Java, so synchronized, mutex, some code. How could this be implemented under the hood when Java is executing on an OS? First, we can get a semaphore for the mutex value. We try to pull down the semaphore, so we are here on the synchronized. If no other thread already entered the critical section, we can execute our code. And finally, when we are done, we put the semaphore up. Yeah, I'm looking at the chat again. Okay. Okay, what you need to remember is that the semaphore always needs to be put up. Okay. Now waiting for data. What this means? Well, sometimes if you have multiple threads, you need to wait for in one thread. You need to wait for a second thread to finish processing or calculating some complicated data, or simply you are waiting for user I/O in the game logic. So how to do this? The simplest, but not necessarily the correct way, would be to create a data available variable, and in the thread A we constantly check if the value is set to true. If not, we wait some time, we check again, etc, etc, etc. And in thread B, when we finished processing data, we set this value to true, and that allows thread A to continue. This is not a very elegant approach. This is sometimes in literature called an active waiting loop, and basically don't do that. You should not do it. How you should do it? Simply, in Java you should define an object that you will synchronize on, and in thread A you simply need to do a wait operation on this object. This causes the thread to go to sleep, and in thread B you simply need to invoke the notify method. So in this approach you do not have an active waiting loop. The operating system will handle, or looking at the chat again. Okay. Okay. Let's get back to the presentation. So when the thread is in waiting state or sleep state, however you would like to call it, the operating system handles all the communication of the notify wait states, and basically you do not need to worry about it, and it's definitely written much better, and the code is much cleaner. Okay, next, application main thread. As I mentioned, that most multi-thread applications have another thread that's called a main application thread, the UI thread, the main server thread, etc, etc, etc. In most cases, a main thread is referred to a UI application, but bukkit also has something that you might call a main thread. So what a main thread is responsible for. In window applications, the main thread is responsible for creating the UI, handling all the user interface actions and system messages. System messages are some special messages sent by the OS to inform the application you should move, you should close, you can repaint, etc, etc, etc. And finally, the UI thread is responsible for reading and writing data to the interface. You need to know that, of course, you can try to write or read data from and to the UI using a async thread, but this in most cases will cause an application crash. Now, bukkit. In bukkit, there is a main thread that's responsible for manipulating the world, handling all of the events, handling commands, handling the game logic, and of course handling all of the plugins. Sorry. So if you have a plugin that has a command, it will be executed on the main thread. This is exactly why when you have a command that takes very long to execute, your server will lag and you will probably experience a TPS drop. According to the bukkit documentation, you can use threads, but you cannot access the bukkit API from the threads. Yeah, that's all I wanted to say about this slide. Let's go over multitasking in bukkit. First of all, how do you start a thread in bukkit? Well, simply, you can either use the thread class from Java and use the good old Java approach in handling all of the threads, or you can use the bukkit scheduler to start a thread. And of course, you can use any third party library that you are accustomed to and love to use. The bukkit scheduler is much more powerful than the threads, and we will cover some of its features just in a moment. Okay, what you can do with bukkit scheduler. Those are only 3 examples. You can do much more with it. First of all, you can start a timer. A timer is a piece of code that is executed by the scheduler every X ticks. The code that is contained in the timer is run on the bukkit main thread. Therefore, you can access the API, but you need to be aware that if this timer code takes too long, you might experience TPS drop and lag the server out. Okay, next. Async jobs or threads. You can either use Java approach, new thread run, or bukkit scheduler run task asynchronously. Honestly, I see no practical difference in those two approaches. I usually use the run task asynchronously just so the code looks better. When you start an async job, the thread is not running on the server main thread. I was looking at the chat, but it's scrolled away. Yeah, okay. We'll get to the questions later, then I will focus on the chat, so I think it will be better then. I will be more responsive to your questions. Okay, where were I? Okay. When you have an async job or async thread, this code is not executed on the server main thread, therefore you cannot access the bukkit API from it. Well, technically you can access and some functions will work properly, but it's you should not access them. Okay, next, dispatching tasks. As I told you, one more thing about the async jobs. When you are running this async task, you do not need to worry about lagging the server because again, it's not on the main thread, so you should not experience TPS drop. Okay, let's move on. What if you are running an async task and you would like to run some bukkit API function? So for example, you would like to change a block on the world. Simply, you would need to dispatch your piece of code, the piece of code that modifies the world, using the dispatcher. In bukkit, you can do this simply by calling a run task. This forces the code that you are putting in the run task to run using the server main thread, and therefore you can without any risk run your code, run the bukkit API. But still, you need to remember that you might cause server lag. And finally, when this code is done, the dispatched code is done, you can return the data to the async task, async thread, using the multi-thread data accessing techniques that I have already shown you. Okay. What's the time? 32 minutes. Okay, finally, the async in AsyncWorldEdit. Well, first of all, I would like to apologize everyone that thinks that AsyncWorldEdit is an async thread, async modification of the world, etc., etc., etc. No, the async is in quotations, so it's only a cheat. Exactly. How AsyncWorldEdit works. It has something that's called a block placer. It's simply a timer that places blocks each X ticks. This is of course configurable in the config file. Each time the block placer is run by bukkit, it takes some amount of blocks from a global queue and places them on the world. The number of blocks that are placed on the world differs because the block placer is constantly checking how many time it already spent on the main thread, and if it detects that it has spent too much time, it's going to stop placing blocks. So that's basically why the BPS sometimes is higher, sometimes is lower. Okay, let's now assume that you would like to do a simple set stone operation in WorldEdit. AsyncWorldEdit automatically captures this operation and divides it into two stages. The stage one, after the operation is started, the set command is started, it is running on the main thread. Therefore, AsyncWorldEdit captures all the data relevant to the command and immediately kills that command. And in the next step, it takes this command data, starts a new thread, so there is some async in AsyncWorldEdit, and calculates all the blocks that need to be changed on the world. So, for example, if you had a replace of 1 million blocks, it would go over. It would go over all the million blocks and check if it should replace them. This, of course, requires accessing the world map. I said that bukkit the API should not be called from an async thread. In most cases, yes, but there is a but. You can access you can access the map if you want only to perform a read operation. Therefore, AsyncWorldEdit has something that I called optimistic get operation. This is simply accessing the world data, reading the world data from async thread. AsyncWorldEdit checks if this operation can be done. If it detects that the operation is safe, it will try to read data from the world. If this fails, or AsyncWorldEdit detects that this operation is not safe and it can crash or corrupt the server, it will dispatch this operation using a built-in dispatcher that's built into AsyncWorldEdit. Okay, when stage 1 is finished, the stage where we calculate all the blocks that need to be changed, stage 2 is started, but stage 2 is performed by the block placer. So all the blocks that were calculated and stored on the queue in stage 1 are placed on the map. So basically, this is all the magic behind AsyncWorldEdit. So calculate all data that needs to be changed, divide it into small chunks, place them on the world. That's all. So thank you for watching. Now we can go to the Q&A. Why did I decide to create AsyncWorldEdit? Okay, this is the question asked from Fostremus. I hope that I pronounced your name correctly. Why? Basically, I created a plugin that was rendering player statues and blocks, large blocks, and it started to lag my server. Then I decided that I needed to find a solution to fight the lag, and the simplest way was to divide the operations into packages. Not long after that, a friend called me and said, "Hey, it would be extremely nice if you could implement something like this into WorldEdit." So I decided to start working on making this more generic approach, and AsyncWorldEdit was born. Okay, next question. Question from Rubik Cube Man. Can you return variables from async threads? If not, how would you achieve something like that? Well, there are a few ways you can achieve this. For example, you could set up a variable that you would like to write to, and you would wait for the data to be calculated, and then simply you would read it with additional thread. I'm not sure that I fully understood your question, so if it's not what you wanted to ask, then please rephrase your question. One thing, what's a question? That was a question. Yeah, sure, you can use collables, but it all depends on the task that you want to that you need to perform, and many other things. Okay, if there are no more questions, then it's all that I wanted to say to you. Thank you for listening, thank you for watching, thank you for questions, and back to you, Zed.
Alright, thank you very much. I think we all need to say a massive thank you to SB Prime. He very kindly offered to do this for free, so massive thanks to him. Definitely go look at AsyncWorldEdit. We used it at CubeCraft, and it does actually make quite a bit of difference and means we don't kill our servers all the time. So yeah, thank you very much, SB Prime. For those who have been watching, if you have any feedbacks about the format or any feedback you want to give us, I'll put the link to the Spigot thread in the chat now, and if you could put all your kind of feedback in there, then we can improve the talks for next time. Some of the stuff which I'm most interested in is the length of the talk. Did you feel that it was too short, too long? So if you could let us know about that, it means we can create the best talks possible for you. So thank you very much for everyone for coming and saying hello and learning about threading. Thank you once again to SB Prime. And we'll catch you all again later in the next installment of the Development Talk series.